engineering hotspot. Today, hope you are doing well. Today I am going to start with RAC, refrigeration and air conditioning. So, in this, what is refrigeration? And in refrigeration and air conditioning, basically there will be two parts. One is refrigeration and one will be air conditioning. Okay. So first I will deal with air conditioning part. Okay. So what will be the general overview, so you will get the entire idea. So in this way I will cover the entire RAC. Okay. So first I will deal with psychometry. Then I will go to summer and winter AC. This will be the AC part, okay? AC part. Then I will cover the refrigeration part. In refrigeration part, first I will deal with air refrigeration system, okay? Then I will deal with vapor absorption refrigeration system or vapor compression refrigeration system. Then vapor absorption refrigeration system. Then different parts of AC in detail. Okay. Parts of refrigerator, different parts of refrigerator. So this will be the overview in which the way I am going to teach you. Okay. So I guarantee you that at the end of the process, you will be able to solve all the problems that are going to come in the competitive exams. So you will be get benefited. Okay. So first I will start with psychometry. So what is basically psychometry? Psychometry basically refers to the study of the properties of mixture. What is mixture? Basically the mixture is basically the mixture will be of air and water vapor. Okay. So the study of this mixture, properties of this mixture is called psychrometry. So in psychrometry, basically I will complete three parts. One will be the properties, different properties, then different process, and then we will solve problems, okay? Problems that came in competitive exams or some new problems also. Sorry. So let's start with properties. So basically, since we are doing with moist air means the mixture of dry air and water vapor. So for to know all the properties of moist air, first we have to fix three properties. Okay, we need three properties to understand all the properties or to calculate all the properties of moist air. Three properties are required. So, as you know that the properties what we used to deal in all the subjects, basically they are pressure and temperature. So here also, it's same. We will take pressure as one, basically barometric pressure. Barometric pressure, and the second will be temperature. No, there are basically we need three properties. One will be pressure and one will be temperature. In this, there will be three types of temperature that I will discuss now. So we will need two types of temperature so that we can fix the properties or the state of moist air. So let us start with the properties, okay? First is the pressure. Pressure basically we can measure with a barometer, not a problem. That is atmospheric pressure. Now coming to temperature. So first is dry bulb temperature. Dry bulb temperature. So what is dry bulb temperature? Dry bulb temperature means if you take a thermometer and just keep it in air, the temperature that is measured by that thermometer or any measuring device, temperature measuring device, that temperature is called dry bulb temperature. So the temperature, it is the temperature measured by thermometer. temperature measuring device. Okay. So this is dry bulb temperature. So this is one type of temperature. There are two more temperatures, but I will deal it. First, we need to know some basics, okay? After completing those basics, we will discuss those two types of temperature. So let's see, what is Dalton's? First, let us discuss Dalton's law for ideal gas mixture. That means you will have a mixture of gases, and those gases are behaving ideally, and Dalton law has proposed a theory for that. Okay. So what is that? If we have different components, okay, different gases. Suppose this is gas number 1, its pressure is P1, gas number 2 has pressure as P2. These are basically partial pressures, okay? P4, and this goes on. If you add this, all the pressures of each component or each gas, you will get the total pressure, okay? This is one property. Then there is one more property, mass. Mass of first gas plus mass of second gas plus mass of third gas, and so on. So many gases will be there. Suppose I am taking this as M, this is M. So if you add the masses of each gas, then you will get the total mass of the mixture. This is for mixture. Then we have density. Okay. Density will be this sum. This is density, okay? Density. Then we have volume. But remember, the volume of the mixture will be same, or the volume occupied by each gas will be same as that of the volume of the container. So the volume of the mixture will be same as V1, first gas volume, is equal to second gas volume, third gas volume. This goes on. You know that mass is equal to rho into volume. Now try to use this property here. How we get this thing? Let's see. Rho is equal to mass upon volume. Okay, this is for mixture. And this we can write as rho 1 plus rho 2 plus rho 3, okay? This goes on according to this property. So for rho 1 you can write as m1 divided by v1. For rho 2, you can write it as m2 divided by v2. For rho 3, you can write it as m3 divided by v3, and so on. Now, you know this mass and this volume will remain same, because v1 is equals to v2 is equals to all are equals to v only. So change it, m1 plus m2 plus m3, this goes on till mn divided by 1. And sum of all this is what? M by m only. So you got, okay, rho is equals to m by v, and rho is equals to rho 1 plus rho 2 plus rho 3. We have justified that, yeah, rho is equals to rho 1 plus rho 2 plus rho 3 plus rho 4 till rho n. So in this way we got this property. Okay, and one more is that you can take temperatures also. Okay, the temperature of the mixture, remember, the temperature of the mixture will be same as the individual gases components. All will be equal. The temperature of all the gases will be equal, and that will be equal to the temperature of the mixture according to the Dalton's law. Okay. We know specific volume. What is specific volume? Specific volume means, and denoting this with this way. Okay. This is actually total volume divided by mass. Okay. So this is actually 1 by rho, or you can take this also, not a problem. So it will be total volume upon m1 plus m2 plus till mn. Okay. So you can write this as, if you take v downward or in the denominator, it will be m1 divided by v1 plus m2 divided by v2. This goes on. So you can write this as one upon rho 1 plus rho 2 plus rho 3 and so on. Okay, so these are some of the properties that you need to keep in mind while going forward for this psychometric process. Why I need this? Because psychometry deals with the mixture, okay, and that mixture is basically the mixture of dry air and water vapor. And water vapor, what? You might be thinking that how water vapor we can treat, air is okay, air you can take it as a gas, but how you will take water vapor as a gas? basically, according to the experiments, they have said that till 3 atm of pressure, water vapor can be considered as a ideal gas. So, if you write for a mixture of dry air and water vapor, what you can write? Total pressure will be equals to pressure of dry air, and writing this PA is the pressure of the dry air, okay, plus pressure of water vapor, PV. Total mass, I am writing it with M. This will be mass of air plus mass of water vapor. These are all according to the Dalton's law that I discussed already. Then volume of air is equals to volume of vapor also temperature P. This will be the total volume, okay, of the container. T, temperature of the container will be same as temperature of dry air, and this will be equals to the temperature of water vapor. You know, mass is equals to volume. So V by M is specific volume, and it will be 1 by rho. So what does it mean? That let me write for density also. Density of mixture will be density of dry air plus density of vapor. This you can write 1 by rho. This will be 1 upon rho of plus 1 upon rho of vapor. So this is basically specific volume, okay? The specific volume of mixture, this is specific volume of dry air, this is specific volume of water vapor. So these are the things what you can write for the mixture of dry air and water vapor.